There we go. All right, 7 reasons to move your code to Visual Studio 2017. My name's Steve Carroll. I am the dev manager for the C++ team at Microsoft. I've been doing that about four and a half years at this point, but I've been with Visual Studio since 2003. I've been there for almost 15 years at this point. So before working on C++, I was also the dev manager for the debuggers and the profilers and IntelliTrace for for the first 10 years or so. So today, and just to be clear, like the C++ team means like I own the compilers, I own the front end of the compiler, the part that actually speaks C++, the part that spits out ones and zeros, and the other side is a different team. But we own the libraries, we own the IDE, we own the C++ extension for VS Code, which I'll talk a little bit about later. And yeah, some of the Linux stuff that we'll also be talking about. So I'm going to kind of use this as an organizing framework for the talk. We're going to talk about a few different areas of the product that we've updated for 2017. I'm going to talk about writing modern and portable C++ code and the work that we've done to make that easier inside of Visual Studio. I'm going to talk about improvements to the compiler to make it the best for Windows. But one of my key topics, like I hope that you walk out of here if you know only one thing, besides my poor pronunciation of German words, is that you can use Visual Studio 2017 to target any compiler or any platform. I think there's a strong feeling amongst most people, because it's been that way for so many years, that Visual Studio is a tool for using the Visual Studio compiler to target Windows. That's not true anymore. And I'm going to show you a lot of different ways in which we're trying to branch out and be relevant, even if you guys aren't Windows developers. And that's actually a great transition point. Can I see, via a show of hands, who in here targets Windows? Oh, okay. Thank you. Thank you for your support. All right. Who targets something besides Windows 2? Like Linux. Let's do Linux first.
Like 2. Also.
Yeah, as well. Also, right? Yeah, did I get it? Yeah, all right. And Mac, or like Mac OS? Okay, cool. All right, good. Perfect. That's exactly what I want. I want to talk a little bit about upgrading, pain-free. If you guys don't upgrade to new versions, I have to get a new job. I love my job. So, I'm going to talk a little bit about how it's not as bad as you think it is, and some techniques and tricks to make that easy for you. Like, for instance, the fact that you can install only what you want to use. In 2017, I am happy to say that you do not have to install C# if you want C++ tools. Now, you should install C#. C# is a great language, but you don't have to. Yes, run faster than ever. I'm going to talk a lot about performance. That means making Visual Studio faster. It means making the code that you compile inside of Visual Studio faster as well. All for the cost of an easy upgrade. And then I'm going to talk a lot about productivity. I'm going to show you stuff today. I'm going to do probably about 15, 20 minutes worth of slides, and then we're going to jump into demos. I'm going to show a lot of things that are in the product today. Towards the end, I'm going to show you some things that are coming in future versions of the product. But where are we? We are here. As of May 7th, we released the 15.7 version of the compiler. Visual Studio 2017 came out last year in March, so we're about, 15 months into this journey. In that 15 months, we have released 7 different updates, all of them with new features in them, many of them with new compiler updates. And if you go into the preview channel today, you can get an early view at 15.8. I'm going to mostly focus on things that we've done in the last year while still highlighting some of the big topics of the year preceding. My illustrious colleague, Marian Luparu, has done a demo called 7 Reasons to Move Your Code to Visual Studio 2017 edition, if you want to see more details on some of the things I'm going to skip, and I'll try to call out what those are. Okay, so this is a special year, 2018. This is the 25th anniversary of Visual C++. So I already kind of gave it away. I am not a 25-year team member. We do have 25-year team members still in the team. So I thought we would start by going on a quick trip down memory lane. Okay. So, all right, things that are interesting, right? Obviously, the 2017, this is the first Visual C++ edition I worked on. This is, of course, the one that was almost my administration was in charge of. And the thing I think is interesting as you look at this slide is that, as far as I know, these were never actually made into boxes. We just have like speculative pictures of what it would have looked like if we had made a box. But these ones, I have one of these. These exist, I promise. And like some big milestones and things, like Visual Studio 2010. This was the big one. This is the one where VCX projects came in and we rewrote all the project systems. It's also, I must acknowledge, the first time ever when you started up Visual Studio, managed code would run. Yeah. We had to do some things with the perf after that happened, but that was the first in there. So 2008 was a good one. Okay, so this was the first one I ever worked on. I worked on the profiler in Visual Studio 2005. This is crazily still used all over the world. I was in China last year, right? And I go into this company, I'm like, I'm going to tell you all about Visuals 2017. It's going to be great. You're going to love it. And I go in there, and they're like, that's great, but we have this problem. Can we show it to you? And I'm like, yeah, sure. Customers first. Customers always right. And so I get in there, and they bring out this, I don't know, vintage, new laptop, right? Really nice new laptop. And yeah, darned if he doesn't show me he's running Visual Studio, Visual C++ 6.0 on the darn thing. And so here's the thing. Boy, was it fast. No, that's not the point. That's not the point. But yeah, actually, like it's funny. Those are the two versions, right? 6 and 10. We had shirts made that said 10 is the new 6, and at the time people were like, 10 is never going to be as good as 6 was. And actually, no. When we go out and see, people stuck on 10 for a long time. But we don't want you to do that anymore. It's great. Okay, this is the first one I ever used, and yeah. Okay, so going back, almost done with my trip, and then we can do things that could be useful to you, I promise. All right, so 2.0 came out in 94, and in 1993, Visual C++ 1.0 came out. Okay, so like maybe a long shot, but did anybody here use it? Yeah! Okay, I did not. That's awesome. One thing about Visual Studio C++ 1.0, I should get the picture into the deck, but like... But this was pre the internet, right? So when you wanted to know how an API worked or whatever, you had to look it up in a book. And that means we had to give you the book if you were going to use the software. And that means Visual C++ 1.0 came with a box that weighed 40 pounds. When they had the 20th anniversary party and they brought all the old timers back, not that old, but they came back because from their private islands where they're sipping champagne or whatever, and yeah, they had the actual box, and we had see if we could still lift it, kind of thing. All right, last stupid story, and I promise I'll do stuff that's meaningful to your lives. So we found. Oh wait, let me set this up. We went on YouTube, and. Somebody had actually uploaded the video for the C++ 1.0 launch video, like where we were going out to try to tell people to do. It turned out it was actually the person in the video. He had uploaded it to YouTube for his, things of glory. So yeah, it's like an hour long, and you can watch it, and they have like all these videos. These like vintage nerds like being like, yeah, man, MFC has changed my life, and it's really funny if you like that sort of thing. So here's a brief clip.
Really professional C++ Windows application in minutes. Ladies and gentlemen, that was Visual C++.
Yeah, right? So watch carefully. In case not at all, obviously, that's the 40-pound box. There was a symphony orchestra behind him during this launch party. And I want to admit that I am, maybe just the slightest bit, disappointed that I didn't even get like a string quartet. So I'll take that up with the organizers later. So yes. All right. So this would have been the really cool part of the talk where I would have told you that we actually had those shirts reprinted that he was wearing. Visualize your masterpiece. But I have to admit to you that I had to schlep these things from America over here to schlep. Is that actually a German word? I don't even know. And so I have a few left. They are not, shall we say, the most common of sizes, but if you're interested, please don't make me take them back. All right. Yeah, we did that. All right, cool. All right, so big deal announcement, right? Visual C++. We announced when we released 15.7 that for the first time we hit standards conformance. And let me stress that for a minute. Like C++ didn't have a standard in 1993, right? The first standard was 98, which was I think the 3.0 region. And just to acknowledge it, we never hit it, right? Like we literally never ever had anything that even came close to matching the standard. Now, in the olden days, that wasn't that big of a deal, right? Nothing was. They were all non-standard. There was no standard. But we worked like crazy over the last 4 years. And so we are now supporting all of 11, 14, and 17. And the key thing here is including two-phase name lookup and expression sphere. Now, these are from the old times, but like basically the reason is at the time, because we were memory constrained, right, we needed to pass through the code. We had to like see if we could make it through the parse and out to code before running out of memory. So it was very important that, especially since two-phase hadn't been defined yet, that was why we did it that way. This was a hard thing to change about an assumption. We are using the same code base as we were in those days. There are comments in it from 1982. So we basically, I've been describing it as we've been flying this plane and releasing every X months or whatever, still rewriting large chunks of it and actually adding that kind of a semantics. We've completely rewritten the parser. Performance is actually getting better as our standards conformance goes up. I should acknowledge, before someone asks me, there are some small caveats to that. We are currently in the process of rewriting the preprocessor. There are some non-conformant things in the preprocessor. Those will go away. And then the top two questions I get asked at this point is usually, but what about Boost HANA? And we are working on Boost HANA. We're targeting one of the updates for getting that working. And the second someone always puts their hand and says, but what about Range v3? Range v3 is also, we're burning the bugs down on it, and we will get to the upstream on it. Okay, so that's fun. Write modern and portable C++. So we talked about this a little bit already. In RTW, we shipped the things in blue, which by that point we'd already gotten 11 and 14. We've been streaming 17 in over the past few updates. And in 17, we filled in the rest of them. I also, including two-phase lookup, which is now complete. I want to stress this. In my team, we send, I want to say 9 people to the standards meeting 3 times a year. We are trying our best to, because we don't want to have these extensions anymore, and we want to focus on pure and real and good C++. We're working very carefully with the standards meetings, and so like the guy who is the editor for this thing is on our team. He's working with the standards committee, so we've had coroutines first. We also did the implementation of coroutines in Clang and LLVM to make sure that there was another way that people who could only use open source tools could get access to that. We have the, by far, I think, most complete implementation of C++ modules. We have very, very little concept support in there, but that is something that we're currently working on. Actually, I want to go really quick to this one more time and point something out that I somehow managed to not do, which is something we're super proud of, which is this, the most complete C++ 17 library implementation. As far as I know, we are the only people shipping a parallel algorithms library at all. And there are a couple other minor ones like that where we were actually ahead. We do not quite have all of C++ 17. There is a type conversion string to, basically the string to I, and string to the F, those are, it turned out, are really, really complicated. Stefan Tilawade on my team, who does a lot of the libraries implementation, was showing me some of the nuance in it, and it is crazy. So that one it'll come in the 15 series. Okay, so as I mentioned, our code base, 1982. If there's one thing that we really, 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 really do understand, it is that much C++ code is legacy C++ code. And when you change around the compiler, you have the potential to make pain for people. We know, because we break ourselves. So the way we try to approach this problem is by adding the /permissive- switch. /permissive mode, but basically saying, don't be permissive. Basically, it tells you to say, yes, I want to opt into these new behaviors where before you did it one way, and now you did it the conforming way. And this allows you to signal this to us. So this is not on by default. If you take your project and you compile with this and you depend on two-phase lookup, for instance, you won't get that behavior until you select this option. There are also some sort of fine-grained conformance suite features if you want just two-phase, but not the other things. But we try not to go too crazy with that. In 2017, for the first time, we added the ability to pick which of the standards you want to target. I want to talk about this one really quick. This is C++ latest. When you select, okay, so we're going and implementing these things in the updates. If you choose C++ latest, what this means to me is that even though, for instance, C++ 20 is not done, and even though C++ 20, when the committee gets together and goes and votes on stuff, sometimes has source breaking changes, this is your way of telling me that you are okay with that. Because effectively, we make no promise whatsoever that we will not break your source code to achieve the conformance of the new standards, even as the standards achieve. So I just want to understand, if you want to use the new features, this is definitely the thing to do. But understand that I can't make a commitment to supporting the halfway done standards. Okay, cool. I'm not going to do a ton of demo in this space, but I feel these tools are criminally underutilized, and so I really want to take a minute and talk about them. The C++ core guidelines, which I heard you mention, Kate, earlier, which suggests to me that you guys know what that is. That, you know, there's a bunch of experts that get together from the community to try to decide what good C++ looks like. This is an opinionated guide. You know, it's not just a lowest common denominator. It's this is what we recommend as best practices. And what we have tried to do in Visual Studio is have the most up-to-date set of checkers for those rules. As well as we have normal static analysis stuff too, which again, I feel is criminally underused. So the Guidelines Advisory Council got together. This is like Bjarne, Herb, Gabby, Dos Reis, and these guys, but also people from Google and also people from Facebook, and of course independent people as well, get together and basically sat down and tried to think of, in these list of rules, which ones are tool checkable and which ones of those that are tool checkable should be tool checked. So we used that as sort of a prioritization exercise to try to decide which ones to do first. And we did. And so those ones are all now available. As an example, there are some ones that will tell you how to use span. Span is a really great way of wrapping the length and the buffer up together so that the tools can check. It's a runtime check, but also we can do static checking to make sure that you're using it properly. So I really want to call those out. These arithmetic overflow checks are in the latest version. One of the things that is awesome about sort of one Microsoft approach that is in the Satya world is we get invited to the security reviews for all of the patches that go on Patch Tuesday, right? So like, for instance, let's imagine there was a browser and it had a security flaw in it. We get to go and sit in on those sorts of like what happens, and they do, you know, deep postmortems on these things to try to figure out how they can basically avoid them before. And that's where these rules come from, right? Like effectively they are, let us never do this again. How can we enforce this rule? And so even though I'll show you an arithmetic overflow check later, it's like the most obscure thing ever, but like these are real. And they break important code. Lifetime rules. Herb talked about this as CPPCon. It's deep, it's cool, it's new. I won't go into the details on it. This is my favorite rule. I literally just added this to the slide because I like it so much. This is, I'll stand in front of it so it doesn't give it away. But like, yeah, look at that. This is a super common bug, right? Oh, right, because this doesn't work, right? I should wear a black shirt next time. Mark that down on my thing. Run a rule. So what happens here, right? Do you see it? So this is supposed to be locking, right? But it's not locking. And the reason it's not locking is because it ain't named. And so because there's no named, basically the scope ends at the semicolon. This is like the dumbest thing, right? Like, can you imagine trying to find that bug in a debugger? Right? I love debuggers. I owned the debugger for 10 years, right? I think they're amazing productivity tools. But oh my God, if you can avoid having to, like that's gold, right? We've also done some stuff like improved rule sets and workflow improvements just to make it easier. Like as an example, I'll show you later, you can actually run static analysis on like one file. Okay, that's compiler for Windows. All right, we talked about standards to death. You're bored about standards. Let's talk about diagnostics. Diagnostics, when we say that in this context, means like the error messages and the warnings and whatnot. We've done a lot of work here. This one was one of our most requested features. This is, again, if you take a look at the code, the initialization's in the wrong order. We know you're doing that wrong, and now we tell you. So we've done some improvements on the template name diagnostics to acknowledge it. We ain't done yet, but they've gotten better. Diagnostic caret, this will, this is another one of those we can't break your code things, so I really want you to understand it. /diagnostics caret, this will tell you the column number that the error is on, not just the line number. So now you're thinking like, okay, good, yeah, that seems like something that you should have done 10 years ago. Right, yeah, so I agree. But like, here's the crazy thing. We tried to turn it on. Yeah, we couldn't turn it on. Why couldn't we turn it on? We broke all of your error logging parsing, right? Okay, so I can't turn this on by default. Maybe in a future version, but if you want that behavior, you have to turn it on. Okay, /external. This is the ability, like if you're doing like warn as error kind of things, which I highly recommend, that allows you to mark which of your header files you want us to ignore. So it's like says this header file is external to my stuff, and so yeah, don't mess with it. Best runtime performance. This is relative to 2015. These are spec benchmarks. This is what I was referring to earlier. When you, worst case scenario, if you upgrade and you build with the new compilers, like in the worst, but, when we found it's like 2%, right? Like, yeah, it's still something, right? But like, as you can see, like X264, which is doing, of course, a bunch of video and audio decoding, right? Like that one was 24%. There are a lot of improvements in here. And so I'm just trying to tell people about them. Security tools, really quick. We've always had some of these things. Use /analyze, please. Test time checks that will tell you if something has gone wrong, like the CRT debug heap. But new in 2017, actually 15.6, /QSpectre. Spectre and Meltdown has been a fun experience for all involved. This is a big deal, right? Like I don't know, like I think sometimes people don't like get that it's a really big deal. This is our beginning, right? Like the /QSpectre flag will put in a bunch of places where it will force it so that you can't do the timing attacks you need to do in order to do Spectre. I've learned from long experience not to go into details on this stuff because I'll just get it wrong. But we have a blog post about it, and I do encourage you to go and take a look at that. It's not for all code, right? Like there's no way to do a Spectre mitigation that doesn't have performance impact, right? So you have to be really careful with how you decide to go about doing this. But if you have, security critical code, it's definitely something to think about. Yeah. Upgrades. This one hurts my heart a little. So for time immemorial, at least since 2008, I think, we've had what we call multi-targeting, which is that if you install Visual Studio N and Visual Studio greater than N on the same box, you can go into Visual Studio and target the lower version number so that you can use the new IDE even without upgrading your compiler. And frankly, that's not my desired state. I want you to use everything, but I want you in the IDE by all means, please. People didn't know that. Like, honestly, we did a terrible job of letting people know that that existed. It still works, but we're trying to make it even crazier, easier than this, which is inside the installer, you can go in and check the 2015 tools, and it will bring the latest version of 2015 down without having installed the other IDE. Because, like, just to own it, the 2015 installer is ridiculous. I mean, it brings down like 8 gigabytes in its minimal configuration. But what will happen is if you use the installer to bring down that, you will get just what you need for this experience. The other thing I really want to stress, binary compatibility between the VS 2015 and 2017 runtimes. The number one reason people say, please upgrade. And they said, no, Steve, we can't. There's this library. And so what that does in our ecosystem is it basically, like everything, like in order commits, right? Like nothing can commit until all of its dependencies have committed, which is a nightmare for us because effectively that library might have a dependence and that dependence has to get done first. And so what we did in 2017, and this is the first time we've ever done this, is make it so that you can link 2015 and 2017 things together. We've kept binary compatibility across the 6 years of those sets of releases. And so that should be helpful. Obviously, again, if you recompile if you can from source or by getting a newer version, you get the benefits of the performance and the security that we talked about. So you should still do it. But this is basically saying that you can do it incrementally. You can choose when and how to pull things forward. Next thing I want to talk about, VC package. I'm actually going to show you a bunch of VC package stuff. VC package is our package manager. Sorry, we wrote VC package, but I don't want to say that VC package is our package manager. We don't want it to be our package manager. We want it to be your package manager. And it's open source, like completely. There are hundreds of contributors. There are now 900 libraries. I hope that when you go to look at it, you will find, and I'll show you later, that many of the open source dependencies that you require are already there. And so I hope all of these things together add up. Okay, and one more, and as I pointed out the last time I gave this talk, honestly, partially due to feedback from German companies, we know, right? Like you want to lock down. You want to lock down on a version. You want to be able to not have it change out from under you in the middle. We try really hard not to break things, but I understand why you want to have that control. And so now, starting in, I think we did it for the first time in 15.5, if you go into the installer and you flip over to the individual components place, you will find that we have checkboxes that are off by default that will let you install just the compiler from the point updates. So you can use that to lock down on a version. You can also use offline layouts to do that. Okay, so real quick through this. Just want to call out the fact that we have a release channel and a preview channel. The preview channel is a good way to, if you want to play with new conformance features before they're fully released, you can do it that way. We always put everything that goes into the release into the preview channel first. So if you see one of our blog posts and you want to play with something, that's the way to do it. I promise you they're completely side by side on the same machine. Like you'll see on my desktop in a minute, I have this one. I'm going to demonstrate on this one. This is the preview one. But I also have this on my machine. We have 4 workloads. Unless you're using them, you only really need desktop or Linux if you're doing Linux, and you should be able to quickly go in there. Fine-grained control over what you want. For instance, MFC is actually quite big. So if you ain't using MFC, uncheck this box and save yourself several hundred megabytes. There will not be an impassioned plea to use more MFC anywhere in this talk, I promise. Any compiler, any platform. Okay, so yeah. So as I mentioned, we want Visual Studio to be one IDE for any developer, any app, any platform. And everything you see on this is something that we know someone is using Visual Studio for today. MinGW works. Use MinGW. It's fine. Actually, one of my employees owns one of the most used MinGW implementations. We have Android and iOS built in. UWP, of course. It's easy to get started. This is, and I will demonstrate this. Our point of view is that for many years, if you wanted to come and bring your code to Visual Studio, you had to make some Visual Studio assets. You had to make me a project. You had to, make me a solution. You had to do it that way. We are trying to turn the boat so that what you can do is take the assets you have and have us understand them. And then we give you the flexibility to be able to set things up the way you want them. And I'll show you that in a second. And keep using your C++ tools of choice, all integrated in the IDE. And I'll be demonstrating many of these tools in a minute. And of course, rich and familiar editing and debugging experiences. Okay, so this is our other big announcement of the month. So as I mentioned, VC package, your C++ library manager, it now supports even those people who raised their hands and said they did Linux and Mac OS. So what happened? So right now, the current status of VC package is there are 969, I think, because I saw Eric tweeted the most recent one that was done, in there for Windows. On day one of us releasing the cross-platform support, we had 350 tested working Linux and Mac libraries. And if it goes anything like VC Package has been going, when we released VC Package 18 months ago, we did the first 20. We basically did like Boost, SDL2, and FFmpeg, the ones we thought people needed to have. And within, months, we'd had hundreds, and then now we have 900. So I hope that this can become a way that you can use this. If you're doing non-Windows development, please give it a try. Kick the tires. Let us know how it works for you. We're trying to be extremely responsive to customer feedback. Okay, so let's talk about cross-platform development. Stop looking at my slides, and I'll use this to tell jokes. No, okay. So first things first. Like I said. There is no opening of projects and solutions in this demo. Instead, what happened is I went in here, I selected Open Cmake, and I pointed it at the Cmake text list.txt file. Who uses Cmake? Yeah, all right, good. So our survey data tells us that there are about 37% of all C++ developers are using Cmake at this point. That looked like about 37% to me, so yeah, it's nailed it. All right. And so we don't want you to have to do special things. And in particular, we don't want you to use the generator to create Visual Studio projects, because that sucks. Because when you do that, every time you make any change to that file, you have to then regenerate the solutions, and then that means we got to unload everything. You're going to have a bad time. So what we're doing instead behind the covers here, we're not like generating those behind the covers. This is like using Cmake in its server mode. And so it's basically natively speaking Cmake. And if you come in here, you can see, we try to do some nice editing here, light up, get some outlining. We just do that. And then it's configuring it as simple as coming up to the Cmake menu and going to change Cmake settings, which brings up a JSON file, which is this one right here. As you can see, by default in Visual Studio, miracle of miracles, our default generator is Ninja. We ship Ninja with it. Ninja is a fast build system. It's a lightweight and fast parallel build system. Works quite well. So that's how that works. So I want to take a minute at this point and come over here to my developer command prompt and show you what I've got here. So this application I'm showing you is a Pong application. And this Pong application has not very much code. But what it does do is it relies on SFML. SFML is the simple something in multimedia library. And so all you do is you type VC package install SFML. It will go and recursively grab all the needed dependencies. It will build them from source. Because of the way that VC package is architected, all of them will work well together. You don't have to worry about, I need this version of that and this version of that. We always have a consistent set of working together libraries. And this one actually has quite a few dependencies. You can see we built it in 3 minutes. And then the magic happens. The magic is VC package integrate install. What this does is it tells VC package tells Visual Studio, and as I'll show you in a minute, Visual Studio Code, where all of those libraries are. And it auto-configs everything. So like if you come in here, you can see this is key here, right? See this thing? Cmake project should use -d, blah, 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 blah. That goes here. That just gets passed through to Cmake, and we spit that out automatically in our templates. You don't have to remember it once you've done that integrate install. Yes?
What's written in this VCP package to Cmake file? There basically some path to the pre-installed.
Exactly. Yeah, it basically tells it how to find things. And then basically what happens is when you go here, and now I'm going to go open document, you can see it's going to pull up the VC package installed version. So I didn't do anything. Right? Like, to be honest, I really like I'm a manager, right? I don't get to write the code much anymore. But I like to play with code, right? And if you see a new library, I just the amount of time to go and get it and get it configured and set up the include paths and blah blah blah, it gets in the way of having fun, right? So this just works. You tell it where your VC package things are, and then all of those things become almost this might be an oversell, but it's like Python, man. It's like pip install whatever, right? It just works. It takes a little bit longer because you got to build it, but it's fun. And I think that's important. And then basically everything lights up. You're noticing all the purple though. Yes, hello.
What is the advantage of VC package over Conan package management?
That is a great question that I should totally know the answer to, but don't have a pat answer to. So Conan was started by another group of people. It's a competing package manager. I mean, like, that's the answer. They distribute in binary form. We distribute purely in source. Ours has the design principle of what I was saying earlier about having a consistent state of them. Like, in some ways, Conan is weirdly closer to NuGet than VC package, but someone else might know better than I. What?
Is it possible, so you're distributing source and compiling on the machine, actually, right?
Mm-hmm.
So is it possible to apply my own patches to third-party libraries?
Yes, absolutely. And indeed, you can do what, like, we've seen people use it to. I should have repeated the question, but you forgot to hold the sign up. Can you use this with your own patches? Yeah, absolutely. Everything's documented. People do that all the time. If you want one particular version.
That's how it works actually on Linux, then, right?
Yeah.
Okay,
yeah, exactly. And we've seen people take their own private libraries that they are not open source and just integrate them into this.
That's what we do.
Yeah.
It comes with a set of like helper functions, which makes it pretty easy to integrate your own patches, your own libraries.
Yeah. And
a set of conventions.
yeah. And my team, like, honestly, like, we try to be super communicative about this. Robert, who is the sort of wunderkind, does that work? Okay. He give him any feedback and he'll get back to you. Okay, so purple. See purple? Purple's interesting. Purple means that I don't quite have everything configured yet. And the reason is because I haven't finished. This has more configurations. Linux. Okay, so now I'm going to show you how Linux works. And now when I convert over here to Linux debug, what you're going to see is that purple turns to red. And indeed, that's what purple means. Purple means there is a version of this for which you are not properly getting the right answer. We want to make sure that you can come in, and when you accidentally write Windows code into something that's supposed to be cross-platform, we can warn you about it. The beauty of our IntelliSense implementation is it's actually independent of our compiler. It has a Clang mode. It has a GCC mode. It has a Windows mode. And so, and you can configure the header separately, as I'm about to show you. So down here, I have a virtual machine running Ubuntu 16 because I was too lazy to update my demo to work with Ubuntu 18. And as you can see, I have done VC package list. You can see these are all the dependencies that it has, and there's SFML. And then I just ran VC package integrate install. So why did I do that on this one? Well, first of all, it gives you this information, which you need. Again, the -c CMake, you can see the path is a little different. And so again, I'm going to copy that over onto the other side. So let's talk a little bit about configuration. The way that you tell Visual Studio that you want to talk to Linux is, there's probably a better way to get to that, but this is what I do. Add, and then you basically give me your host name, you give me your username, and you give me either a password or a private key, and then I can hook it up. We've had this working for about a year, but in 15.7 for the first time, we've added the ability to do remote header IntelliSense caching. We also changed how this works, so it no longer does it the hard way. It uses rsync to make sure that it makes minimal updates. So this is a big change. So what I'm going to do, now that I've done VC package integrate install, I'm going to come up here, because I did that on another machine. Visual Studio doesn't know it. I'm going to trigger that. That is going to trigger remote header IntelliSense to start syncing. And if you watch here, you can see it's going through the includes. So again, I set up my headers on Linux, pointed Visual Studio at the Linux box, and said, go get them, Tiger. That's what happened here, right? So
can I also use the Linux subsystem?
Yes, and yeah. So and actually, while it's syncing, let me do this. The Windows subsystem for Linux is really cool, and like you can do this, guys. It's great. This is not a VM. This is a subsystem. Windows, like, it's running natively. And when you go to the store, and I don't think I have it up, but I'll just show you really quick. If you go in here and you type Linux and the demo gods smile upon you, da-da, and you say get the apps, okay, like totally, all right. Run Linux on Windows, and then you can pick your distro, man. You can pick which one you like. Like Kali is like special for like people who like super like security stuff, and I just know Ubuntu because that's what I run my media server on at home. And then yeah, so to use this with our stuff, now that I have this going, I can basically set up SSHD doing apt-get install, or whatever your favorite package manager is, install SSHD. And then when you go into that configuration UI, you just do 127.0.0.1 localhost, right? And it'll hook up to this. We've also been slowly adding in features to make it more native. Of course, those things are only available on Windows 10. So where was I? Did it work? Did it work while we were talking? It did. Look, the red's gone. And so now, when I go in here and I do this, in theory, what will happen is it will bring up the version from the Linux header cache, right? So that doesn't really matter here because they're basically the same version. But like, you can do the same thing with this. And then like, you can see like, let me tell you how much my version of the library does not have Free Software Foundation incorporated in anywhere inside of it. Trust me, the lawyers would tell me. Okay, and so yeah, so we talked about, so now we got everything we can build and edit, right? So next, we want to get the full experience. So we go in here, we go to debug and launch settings for Pong. Like you see, I have all this stuff set up but I'm not actually setting anything custom in here. These are all default templates. The only thing I had to change, which up here on the first one, is this. Like I basically had to tell it what my display number was. And now when I click this, what you'll see is it's syncing the files over to the remote machine, which is here. And there we go. Debugger kicks off. We're in here. We have the ability, just like everything else, it's the normal Visual Studio debugger. Under the covers, we're using GDB to do this work. But we've written all the things to wire it up to the Visual Studio IDE experience. So we get really good feedback on it. And then, yeah. And then now let's watch me play Pong. Yeah. Oh, okay. All right. So that is Cmake for Linux with VC package integration. No config. Next up, I want to show you something a little bit more industrial sized. That was not the most sophisticated of applications. And you folks are all professionals working on large, gnarly, impossible to understand, hard things all day long. I'm just, filling some space while the thing loads. So, question, yeah.
Do you also support Cuemake?
Do we also support Cuemake? Not yet, but one thing that I'll talk about it now. So I showed you the Cmake thing. The Cmake thing, we need the Cmake thing to be magic. Like, we just want Cmake to be magic. But what we also want is for you to be able to wire up your own thing. And so, for instance, when I do the Sigwin or MinGW version of this demo, we just edit a couple of JSON files, tell it what the include path is, tell it what to launch under the debugger, set a couple of options to GDB, and you're good to go. So I would love to get Cuemake going. We haven't worked on it, making it beautiful yet. Are we done? Wait. One last question while I run these unit tests. Okay, no. All right. Hey, look, unit tests. Who tests their code? Okay. Our surveys also tell us that you don't test your code, but we hope you will now. So yeah, one of the unit tests runs the app. That's not really a unit test, but that's fine. So for the last, since 2010, that beautiful blue box, we have had the Microsoft sort of C++ test framework in that, and you don't use it. That's okay. I don't mind. And so what part of our whole topic here is, we'll come to you. You don't have to come to us. And so all of these are Google tests. So we now have in the box, I don't know if you noticed it when I was showing the installer earlier, we have both Google and Boost test built in, starting with 15.7 and later. All that happened there is while I was subtly distracting you, the tests were, when you build, the Unit Test Explorer thing will scan your build, looking for Google and Boost tests or MS tests, and then it will populate this window on the left. You can mix and match. We don't care. We'll find them, and then we will run them. If you've never used the Test Explorer, and again, we know you don't, it's actually quite convenient. You can set playlists of tests up here. You set it so that this red bar will tell you when you've broken stuff. You can do all sorts of configuration. This is already probably running long, so I'm not going to show you this, but you can analyze code coverage for your tests. This was the first feature I ever wrote at Microsoft. I know. Anyways, so yeah, all that's in there. In 15.7, you can actually click on these to see this is our first entry into CodeLens for C++. We added the unit test provider so that you don't have to have the test explorer. You can just explore things. You can rerun the tests directly from inside the source if you really want to stay source focused. So that's that. Okay, so back in Cuemake is awesome, but also complex. So this is open folder. I should have showed you how I opened this, but I was telling some stupid joke or something. So I showed you before Open Cuemake, right? And I think you all are very familiar with Open Project and Solution. But this one is folder. So this is how you basically would handle, first of all, unstructured data. And otherwise, if you want to point me at your whole root of where your code is. And so that's what I did. And so this is Solution Explorer opened up in folder view. And you can see this is basically just what's on your drive, right? These are the folders, et cetera, et cetera. And we determined that there was a bunch of Cuemake stuff in there. So that allowed us to configure it, which was great. But it's kind of confusing, right? So like I happen to know that the tests are in here, and I think it's that one. And so this is the actual Cuemake list that text that's controlling things. Yeah, so what we did is we added this thing called targets view. And this tries to create a more logical organization of your Cuemake data that 37% of you are using. It looks like a project and solution, and it allows you to see the structure of your more complicated Cuemake thing. So like, for instance, in here, you can see this Cuemake executable has a reference on these 6 libraries. And you can see that, yeah, this looks like, from folder view, it looks like there's only one CPP, but now when you do it in this way, you can see there's also source files coming from all these different places. So that's cool. So here, this one's failing. And this is the one that's failing. It's because I guess it ran for 2. Well, let's ask it. Okay, so it only took 2 seconds, and it should have taken 4 seconds. Okay, I'll fix that. So let's go to definition, and I'm going to fix that, of course, by adding sleep. And what will happen if I have it configured right, which I might not, because I didn't check this one beforehand, is eventually that will purple squiggle. Again, the purple squiggle telling you that you can't really use sleep because this also has a Linux configuration. So yeah, that's how this works, usually. Cool. So that was my Cuemake stuff. Now I'll switch back. Okay, so we covered some of this ancillary material while I was talking. So you can use OpenFolder for any non-MS build projects. You can do this whole set the JSON things. If you've used VS Code, it's not exactly the same, but it's very similar. You edit some JSON files that tells us how to configure it, and we're good to go. As easy as doing that. We have some new heuristics that will help you get set up. It'll give you like little light bulbs to say, okay, try adding this to your include path, etc. And so that should be very useful.
What happens when you have Visual Studio projects and solutions in your folder or under your folder?
It should still mostly work. You can do that. I'm trying to remember exactly what the caveat is. It will definitely have IntelliSense. It will see that they're in there. I don't recommend it. It's kind of a confusing experience we find when people actually use it. I have seen people use it so that they don't open like a solution because they don't want all the other code in there. But I don't know.
My use case would be we have a solution for the code and a solution for the unit test, and they are distinct. And if I want to see all the code from the unit test and the production
it will work. I'm just saying there will be some like it won't.
It won't find the test.
I think what it is it won't have the union of the two solutions information in it. It will probably pick one. And I'm not sure exactly how one configures that. You can follow up with me afterwards. I'll try to figure out what the actual answer is. We talked about Cuemake. Oh, that's what I forgot. Thank you. Thank you, slides. If you right-click in here, remember I talked about horribly underused features? You can now come in here and run code analysis in your Cuemake solutions. It'll be wired up. It will use the default rule set. You can use this to quickly start doing that. You can also come in here, and this was by far the most requested feature in Cuemake, is the ability to compile a single file. While I'm here and remembering that I forgot things, this is VS Code. VS Code's great. Love VS Code. And the thing I want you to know about this one is, again, 0 configuration. VC package, integrate, install. Not only does it go and tell Visual Studio when you have a project how to find, the header files and whatnot. And just to be clear, what will happen if you use like that in a project or setting is a solution is you can like literally just pound include those files and it will just work. You don't have to go fiddle anything. And now we have that experience for VS Code as well. I installed SDL2, and so here when you create a default cpp properties.json, we will, after the integrate install, add in the paths to this so that you get that same no configuration experience for VS Code. Okay, great. Back here. Am I like way over on this? You're all having so much fun. The time's just flying by. All right, Linux targeting. I don't care what Linux distro. It can be in the cloud. It can be on your desktop. It can be the Windows subsystem for Linux. Thanks for asking. And as long as I can SSH to it, as long as it's got some C++ tools installed on it, we can use it. We have an MS Build-based project system that we started with, but now we are pushing people towards using the Linux Cuemake stuff as well. So yeah, we've been working on Linux for about 2 years. And of course, all the reasons I said we're working on Linux were true. There was also a hidden reason that's no longer hidden. Last week we announced the Azure Sphere project. Did anybody see this announcement? Does anybody here work on embedded chips? Little guys? All right, good. Azure Sphere is a Microsoft project for building a secure microprocessors. And in particular microcontrollers. So this has like an A7 and a couple of M4s on it, ARM chips. It also runs a Microsoft enhanced version. Well, there's like a right way to say that. It's Linux, guys. It's got Linux on it. And so we were building the tools for Linux, and that was the sort of happy reason why this exists. So the idea behind this thing is they took a bunch of the security practices that were developed for Xbox One. Xbox One has yet to be hacked. Yay. And so a lot of those things have, well, for us anyways. Yay for us. Sorry if you're trying to hack it. I know what you people are up to. No, okay. And so all of those techniques went into the design of these chips. The idea is that you can take these chips, put them inside of your refrigerator, I don't know, fancy sports car. And it has a secure OS and a secure cloud connection, and it can like securely update itself. It's actually quite cool. Okay, performance. Who cares about performance? It's just C++. Okay, yes. So to start with, performance of Visual Studio itself. This is a large open source project with 4,000 plus projects. It may or may not be a browser. 2015, when we did it, it took 17 minutes and 30 seconds just to get to the point where you open the solution for the first time. And then the IntelliSense population, the thing where it's going like churning through the files, that would take an additional 21 minutes for a grand total. I love that we put the error bars on here. That's great. Yeah, because don't be mad at us, man. Sometimes it's only going to be like 20 minutes, not like 24. So in 2017, we did a bunch of work on that. We pulled it down. And of course, you were up and running in 4 minutes and 20 seconds. And I mean, to be clear, this thing is huge. And so we hope that by kind of focusing on it, that we'll make like normal sized things be absolutely blazing fast. And in 15.7, we cut it in half again. And no, we won't stop. Yes?
Performance increased with finding references because it was very simple.
There's all this white space. I can't wait to find out what's in it. All right, yeah. So this is subsequent C++ solution load, same project, and now and so of course it's always going to take us time to do that first set of populations, right? We are really literally chomping over every C++ file in your thing, building up a database so that we can more quickly find all of your references. Yeah. Memory usage, again, not 2.23 gigabytes. Remember, 3 gigabytes is the danger zone, and that's been cut in tiny pieces. Debug session memory usage on the same project. From 2015 we were at 3.32 gigabytes, and in 15.7 on the same thing we're down under a gig. You can see when the time to hit the breakpoint, it went out of memory in 2015, and now we can get there much quicker. Hey, I didn't lie. Okay. Find all references and rename refactor, which is basically the same thing. Rename just basically calls find all references on the thing and then just figures out what it is, right? Yeah, we did some work on this in 2017 RTW, but in 15.7, and actually 15.7 itself, not like one of the ones behind, we started adding some parallelization to it to try to make it even faster. I have one of my best developers working on this. It's critical to us, and my hope is that Unreal Engine, if we can get that one, again, it'll be a good proxy for others. It's quite large, and frankly, it's used by a lot of people. OpenFolder and IntelliSense population benefited from some of these techniques as well. But oh wow, my favorite we use the xkcd here with the people sword fighting and saying, oh yeah, I'm compiling. Oh, carry on, right? So I'm trying to ruin all of your fun. You know, like think of all the coffee you could have had in the really long bars from the 2015 era. And same thing, now your compiles. So this is a full build. On full builds, this is another one of those fun things where I go on a first party. AAA Unreal-based game engine, and I'm not saying what it is because you won't figure it out. I don't know, or a custom AAA game engine. Both of them, we sped up their full builds by about 15% when you moved forward to Visual Studio 2017. But that actually wasn't our focus. We tend to think, and I think with good reason, that people do incremental builds most of the time, and so we really focused our energy on making incremental build faster. And so, I wish I could just say the name. We made it 4 times faster. We made the other one 2.4 times faster. A lot of this is actually the linker. Linker turns out to be for very large games, and in particular, does anybody do game dev here? No. Very serious. Okay. In game dev, they use this, there's not a great term for it, but they call them Unity builds, but not like the capital Unity with the video game engine, but lowercase u. I call them lowercase u Unity builds, which is when you like basically pound include star.cpp instead of using precompiled headers and stuff. It's like super dangerous because you can get semantic changes if you're not paying a lot of attention. Yeah.
Is your linker actually something you're actually working on, or some guys actually working on improving stuff like
oh yeah,
LLVM is doing or GCC is doing with Gold?
Yes. That's what this is.
Repeating the question.
Oh, repeating the question. So in the GCC world and in the LLVM world, there's a lot of investments going into their linkers, and indeed the LLVM linker, LLD, is lightning blazing fast. Yeah. And yes, so basically this is us investing in our linker and trying to revise the design. I will not say that I think that we are done. We are not done. But we have some good improvements, and we have a path forward, we think. Oh, one more thing. I guess it doesn't help a ton for, like I said, the Unity build thing is one of the things that we really made fast. But between this 47 seconds and this 34 seconds, a lot of that was, feel free to grab my email address later and I'll send you the slides. But this document is, yeah, I know you can't see it. It says AKMS VC throughput is a list of recommendations that we published. Like, for instance, we keep finding these /map settings inside your, I don't know, 10-year-old project file or whatever. This thing is slow. We made it faster. Like, we don't think you should use it, but we made it faster anyways under the assumption that nobody ever changes things that work. And also, opt no ICF is another. There's a whole list of things that you can do to try to do that. But we're going to also start building some tools to help you analyze your build, and we're all going to work on this together. It's going to be great. Okay. All right, productivity. Demo, productivity. All right, great. This is my last demo, and then I'll let you guys go drink beer. Oh, I forgot to do the... Sorry. I should have prepped this. Now I have to tell jokes again. All right, so for this last one, everything I showed you up until now was something that is already in your build today. This one, I'm going to show you some stuff that's coming in 15.8. And this is the first time I'm going to open a solution or a project. Okay, this is OpenTTD. It's like one of these I think it's like based on Railroad Tycoon. It's like an open source game. But first thing I wanted to draw your attention to is, hey, look, boost test, more testing. So yes, we can do this. Now, as the parsing files and solution completes here, And I won't run the tests. I don't think we really need them. You can just trust me on which ones passed and which ones failed. Finish up, buddy. Finish up, buddy. Ah, there they are. So today, our final color for squiggles today is green. Green squiggles are new. As I mentioned, I think 3 or 4 times at this point, so I think you're going to remember it when you leave, is, boy, are the code analysis tools underutilized. And we know why, right? Like, the first time you run code analysis on your code base, I'll tell you, like, I do, like, my crystal ball, what's going to happen. You have a lot of violations. I'm sure of it. Like, I've watched it a million times. And what happens is people, they build their thing, they throw the /analyze switch, they twiddle the knobs a little bit, and they go, what was I thinking about? And they go off and they do something else. That's it. It's too much, right? Like, it's too much. It just makes you feel sad. Who wants to use a feature that makes you feel sad? No one wants to use a feature that makes you feel sad. So how can I make you feel happy? And my theory is that if you can do it like kind of one file at a time, or like, hey, I'm actually working on this code, so I'm willing to make a change because I'm making a change already, and I don't have the problem of, but no one knows how this works. That is so very common amongst the C++ community. I give you green squiggles. Hey, we talked about arithmetic overflow. And it turns out this is, whenever you see this parentheses io.4 kind of thing at the end, this means that it's one of the CPP core guideline checkers that's giving that warning. And so I know, like, again, -1 shift, well, why, Steve? Why would I have done that? Why is that a thing? Well, we talked a little bit about how we figure out why we need these rules, right? So yes, trust me, real code, real pain. -1 shifted left 10. Okay, this one's a little bit more understandable. I tend to think this is another one of those ones where it's like, yeah, I mean, it'd be great to adopt const.expr, but I have all this code. And so it's a thing of beauty, but let's go in here and hover. Oh, come on. Oh, come on. There, I got it, guys. Change declaration to use const.expr. Would you like this? Should we ship it? And you can see we give you a quick preview, and I click the button, and then it just changes the, oh, really? I got it. Yeah. All right, good. I'm as good at that as I am at Pong. All right. And finally, in my ongoing love of potential security violations, value 3 is outside the bounds of variable stations. Only index into arrays using constant expressions that are with bound. Hi. Okay. Nobody saw me. No, it was fine. It wasn't. And of course, this is I like this one, right? It's like station 1, station 2, station 3. Oh, right. 0 based. Okay, so you fix that and the green squiggle goes away. All right, so that's good. I think these are things that are going to help people. But now let's talk about my favorite topic. Let's talk about how great macros are. Yeah. All right. Macros are not great. Macros are bad, but they exist. So let's talk about them and what we can do with them. So did people use peak definition? I was watching people code at this conference I was at earlier this week, and no one uses it. I love it. It's so cool. All right, so let's look at this. So surface area. So what does it do? It's like it gets surface area of r times r, pound define pi. Oh, look, a green squiggle. I wonder what that could mean. So again, this time you can click on here, and you can convert that macro to const.expr. Oh. And then it shows you, hey, I know, wouldn't it look like this? And it shows you all the places it's being used. So like you can see not only, like what damage you're potentially going to do, because the macro, God knows, right? We'll come back to that in a moment. I'm building up suspense. Is it working? Okay. All right. Yeah. Great. It's a regular expression. You said like if blah, pound define blah, blah, blah. That's easy. Show me something impressive. Okay, fine. This one's a function macro. This is going to be a little trickier, right? It's probably too much for us, right? No, it's not. It's convert macro to const.expr. What's it going to do? Oh, look at that. There's like multiple ampersands in there. Use decal type. What's not to like? So let's apply it. All right. This is fun. This is fun. We're going to have fun. Finally. All right. So this is, again, macros are the best thing. And as the best programmer, I want to use them to their fullest potential. So I'm going to go in here. I'm going to do rect area, which again just multiplies the width and the length. I'm glad that person abstracted that idea out. And now I'm going to do that. That'll teach them. So of course, what does that do? Hey, I wonder what will happen if I hover over this macro. Yeah, that will expand to int star p. Oh, hey, look, it expands what you did in your macro. That's a useful tool in and of itself. All right, so now I've shown them. And so now I'm clearly going to break this. And when I do this, and I do convert, oh, and there's not 2 of them in the thing, and I get the second one because that's a bug. Oh, this macro could not be converted to const expr as you are some sort of jerk misusing it. Yeah, so that's helpful. And then you can come in here and actually, we'll put this in a better place once it's done, but it actually even tells you the line where the great violence has been done to the code base. So that's useful. Okay.
Can you try the bootstrap? Yeah, that's what we might.
What did you say? Did I just walk into a trap? I'm not sure. Let's see. What does it do? Let's hover over it first. Do you want to expand that? I'm not sure you want to expand that. We can see if it breaks. I can file a bug, right? No. You got to go to the, well, I got to go to the definition, right?
That works as expected, right?
All right. We knew it was a macro. We're halfway there. Oh no, it must have been somebody doing that rect area in P thing. That must be the problem. It's a rough crowd, man. I tell you, it's a rough crowd. Does anybody ever use templates? Templates? Fans? You like them? You know what sucks about templates? Okay, so I should be careful here because I was just making fun of macros and trying to convince you that they were terrible and you should remove them from your code with Visual Studio 2017. But I'm not trying to convince you to take templates out of your code. You can go ahead and keep using templates. You can say I said it was okay. But man, it's just not a great experience. And I don't think it's a great experience anywhere, right? Like you come in here, let's hover over begin. Oh, it's of type iter. And then you come in here and you go, begin, and oops, and you learn to type, and then you go like that, and you get nothing. You get nothing. And why do you get nothing? You get nothing because I don't know, right? Like there's nothing to know about it. And so, you know, where'd it go? Sorry, I need to get something. I'll be right with you. I changed my demo flow around, and now I can't find the code I need. Is it in here? I know, let's use find all references. That'll work. Maybe not so fast, I guess, but yeah. I keyed. Yeah, there it is. There it is. Okay. So, but let's imagine that when you're writing that template, right, you probably have at least some idea of one of the specializations that you're going to use it with, right? And so if you look up here, you see this T thing? This is new. So what you can do is you can come in here, and if you're using a reasonable level of font size and not trying to make it so the people in the back can see, and you click this guy, and you paste in a potential specialization for what that is, and you hit OK, now suddenly things actually kind of work. And you can come in here, and when you type begin, you can actually see what's going on there. So when you're making this template, yeah, of course, it's not true for everything. We're not going to catch every possible thing that you've ever done. But, you know, you'll get help while you're writing your code. And this was just sad and pathetic, and it didn't even work. What? Oh, yeah, sorry. Yeah, oh, okay. Yeah. Question from the cameraman.
Will I be able to put a concept in there soon?
Oh, will you be able to put a concept in there soon? As soon as our IntelliSense compiler is updated by the vendor that we use for it, yes. Was that a good dodge? Did it work? Okay. All right. So that was my fun productivity demo, and I'm almost done. And I swear to God, you can go. The beer is close. Is there beer? I'm promising something I don't even know. What's up? All right, productivity. So I talked to earlier. There's that other video of us doing like even more stuff. Oh, I totally forgot to show this. I'm going to show this right now. We shouldn't forget to show this. I know, I'm such a tease, right? Let's search for Clang. Will that work? It will. 15.6. In 15.6, we added support for Clang format. And it's beautiful. Clang format's really good. There's nothing wrong with Visual Studio formatting. You can keep using it. We're never going to get rid of it or anything. But this was a huge ask from people. And so I showed you the open folder thing, right? Where you can go in and just say, like, toss it at my source base and then see what happens. Well, if your source base has a .clang format file sitting in it, we would have ignored it. But now, the first time you see one of those, we'll pop up a window that will say, hey, do you want us to actually use it? And then we'll go and fiddle all these settings for you. But we've also come in here and given you opportunities to directly select the most popular of the default formatting styles. The number of them made by Google is distressing to me. But yes, go ahead.
Can you add your own?
Yeah, you can. If you just put it in the folder, we'll pick it up. Yeah, so just do it the way you would have done it in any other tool, and we'll just accept it. All right, let's see how many more demos I forgot to do. Yeah, control comma is really great. The final references improvements. In addition to the performance stuff, we've added the ability to do a whole lot of different filtering and grouping on there to make it a more effective tool for you to go and really do your big old refactoring. How did I not show control click? Control click, if you hold down the control click key and you click on something, it works like go to definition. It's just super, it's like it saves you seconds, but those seconds can add up over time, right? We added std function debugging. This is the ability to, if you F11 step into a std function or any of its variants, we will actually go straight to the place where you're trying to go and not through the 33 levels of indirection to get there. Run to click, yeah, all sorts of good stuff. We updated the image watch visualizer, which means we had to go find the code for it because it was written by an intern in MSR. So that was fun. We talked about the unit test. Did I say that out loud? Right, and finally, because you guys helped build it, I feel sad sometimes because I think people think that we don't actually check these things. We totally check these things. Indeed, voting on these things is a very, very good signal to us, right? So I'm sure you now have even more things you want me to do because you're never satisfied. And that's great. I don't want you to be satisfied. I want you to tell me what to do. So go to visualstudio.uservoice.com. Just like last week, I think we closed out 10 or 15 of the features that were shipped in 15.7 as suggestions, like Clang format was one of them. Clang format was deeply requested. We did image watch only because it got voted up so high here. We didn't even know it existed, to be honest. We're not graphics programmers, so we didn't know that people needed it. But this was a great signal to tell us to go and do it. I don't know why we choose this example, but we once said, hey, we don't think anybody's using this, so we're going to go ahead and start turning off support. We never do that immediately, but we sort of signaled our intent. And people are like, no! And okay, great, we won't. So blackmail us, it's great. Second, also, report a problem. I know we have work to do to make this even better. I get complaints frequently about the fact that putting code into it is not great yet. But this is another thing that I promise you does not go to dev null. This goes to me. So, again, votes are great. If you could just search for your issue that you have and see if somebody else filed it and then push the plus button, it's great. It helps us know which ones to do first. We're going to do them all, but tell us which ones to do first, right? So that's great. Yeah, we fixed a lot of things. So summary, I'm already long. You don't have to just read that. Yeah.
I have a question. Which from the features are only with enterprise?
I love this question.
Because
I love this question.
Most of us just use professional.
I'm happy to announce that nothing I showed today is in the enterprise SKU. Nothing. Nothing I showed today. Everything I showed today is in community. It's in the free edition. It's all there. Yeah. I didn't even have to pay somebody to ask. All right, great. All right, so I said this already. I'm going to leave these here. You don't have to take a survey. You can, if you want a larger shirt, that they're here. And fade to black. Okay, thank you. Danke. Yeah. Stop. With Visual Studio 2017 launch. Yeah. It's on YouTube. You can go watch it. That's funny. Okay, cool. Yeah, I'm happy to take questions. I'm happy to take your questions later so you guys can, anything is fine. Yes?
Yeah, so what is happening with OpenMP standards? So you currently support only 2.0?
I only currently support 2.0. That is the correct answer. Can you do me a huge, like, this is, again, you're doing a great job of reinforcing my things. Please go to user voice and click the button.
I did actually.
Oh, why do we not do OpenMP 2.0 and lower? To be honest, the answer was really because we didn't think anybody cared. Like, I mean, obviously we thought somebody cared, but not many. But I'm hearing this over and over again. So we are discussing it internally now. I can't make any commitments, but we have some ongoing discussions of how we would update that. And we've been talking with Intel about it and stuff. Yeah.
Yeah, because I'm coming from scientific computing community simulations, and use this quite
Right.
So there's a similar problem with CUDA, right? I mean, they
CUDA, yeah. Oh God.
Out of sync from time to time. So do you
From time to time, I think is that was kind of you. I appreciate your willingness to spare my feelings. No, CUDA has been horrible. We need to get that right, and we've started talking to them. Sorry, we started talking to them a while ago, but we need to figure out how to work together better. We just haven't gotten that right yet. So what keeps happening is they're testing 3 versions ago. They release less frequently than we do, and so CUDA is inevitably, and of course it's not open source, so we can't build it. So this is another thing I'd just like to make a point about really quick, which is if you have if you have an open source package, if you have code that you do not want me to break, obviously we have lots of tests, guys. We build all sorts of real world code. We license every commercially available C++ test library to make sure that we stay safe, so that we can continue to make changes and not hurt the world. But if you own an open source library, I will selfishly ask that you add it to VC package, because if you add it to VC package, I will know the day after somebody checks in a mistake, and it will give me the opportunity to fix it before anybody sees that thing, and I don't have to do some servicing event. So definitely, if you have an open source library, please take a look at it. If you have trouble, it's very easy to add a new package, but if you need help, just reach out to us. We'll help you. Of course, I can't do that for CUDA because it's a closed source thing. We're going to get there. It's important to us. It's important to them. We're going to get there, but just acknowledge it. It's not great right now. So, but in terms of practical things that you can do, given the fact that the world is less than ideal currently, it's another one of the reasons why we added the ability to go get a minor update. So like right now, I believe that the version of CUDA that they just released does not work with 15.7 because they were testing against 15.6. Look up the numbers, don't go by what I said. And so what you can do is click into the 15.6 version, and I'm sure by the time they get to the next one, they'll be on 15.7. I hope that what will happen is now that we have locked 17, that there won't be as many ways for them to break going forwards. There's a what actually ends up happening is they compiled our headers through their compiler, and it's a different compiler implementation. And so if we use C++ 17 features in our libraries, which we do, even in C++ 11 and 14 mode, they get out of sync. So we're trying to figure out what to do architecturally so it stays great, but it's not great yet. So use the fallback position, please. Thank you. Yes?
Do you plan to also invest in MS Build?
Do we plan to invest in MS Build?
Continue to invest in that?
Yes. I had a meeting with them right before I came. We're definitely going to try to do stuff. They do stuff for us now. We really want them to do more for us. But yeah, it's intended that certainly it will stay alive forever. But yeah. Is there a particular thing you want us to do? Or?
For example, how to speed up builds.
Yeah, that's our number one ask to them, is to help us do parallelized MS Build.
Some tool that was supposed to be released, but I think it was developed by one of your interns.
Those crazy interns. It's always their fault, never ours.
Includes, for example.
No, that wasn't an intern. Yeah, we had a header, pre-compile header tool, which we then released and had to unrelease because it didn't work out quite the way that we wanted to. Yeah, we have some plans in this space, but it's early days, so I don't want to kind of overpromise. Yes?
I always wonder why the debugger doesn't get any major features, like the time travel debugging would be cool.
Yeah, so the time...
Data points would be cool as well.
Yes, so no, I shouldn't. We are working on some debugger things for 15.8 and 15.9. Some of them were on your list. We have, but I want to be clear that we haven't done the. So James McNellis working on the Windows debugger, the WinBag WinDBG is that time travel thing. We haven't started working on integrating that yet. But because our theory, at least, is that people can use the Windows debugger and we can really learn about how to make that scenario work. Because we have to figure out how to make it work nicely with the IntelliTrace stuff and in the existing debugger. It's it's on our list. We're definitely going to add some new debugger features for sure, as well as perf. Our number one ask in working with our debugger team is to help continue to pull some of those numbers to the right with the memory usage in the debugger. That's our main area of focus right now, but we are going to do some improvements in the 8 and 9 thing. Yep.
How is the compiler chosen for the VC package?
How do we choose which compiler to use? You mean like on Linux?
No, like when I do the VC package, install, integrate, whatever, when it builds the package, what compiler does it use? Can that be changed?
I believe that it can, because I think that's how he did the initial testing on the Linux stuff to see which ones will build GCC. I don't know offhand, but if you send Robert a mail and you can find on the VC package alias, he'll get back to you. Everything is, all the source, it's completely open source. So I'm sure if you popped open one of those .cmake files, you'd be able to figure it out. But we can also answer the question if you send mail to the alias.
I guess I can answer that.
Yeah.
I'm using it actually, and there are variables.
Yeah.
You can point it to the proper compiler installation. It does not. It can't do everything. It has. It recognizes certain ranges of the tool sets.
Yeah.
That works basically.
Yeah.
It tries to pick. It has some logic to pick some sort of most recent installation, but you can point it to a specific one.
Yeah. Cool. Yes.
Why does the Test Explorer has to find all the tests before I run a specific test?
Yeah, that's a good question. Why does it have to discover all the tests? This is a big area of investment right now. The answer, of course, is that's how it was designed to work. It was designed for C#.
I somehow feel that Visual Studio 2015 does a better job than 2007.
In terms of its ability to scan?
Yeah.
That's actually really interesting. Okay, I don't have a good answer, but we should take a look. I should be writing things down. Yes.
Does Visual Studio Code have first-class C++ support?
Oh, yeah, I wanted to talk more about that. Thank you for giving me an opportunity. So let me talk about how VS Code works a little bit. Oh, you want to see there's another demo I forgot, so I'll do that too first. All right, so VS Code, if you haven't used it, first things first. This thing right here, the C and C++, when you install it, you'll get good editing of C++ immediately. It will highlight stuff, but you won't get real IntelliSense. And indeed, if you had used this thing a year ago, you were getting even if you installed my extension, you would get really basic experience. It was basically the browsing things, go to definition would work, but not the real IntelliSense and stuff. So what's been going on, how this works is, as I mentioned before, we have a sort of separate code base for the IntelliSense compiler. And so what the C++ extension was, is us slowly but surely taking our entire IntelliSense code base and making it cross-platform, because anything we do for here has to work on Linux and Mac. And for those of you who have ever taken a code base that was written for Windows, has lots of strings in it, and then tried to make it work on another operating system, you know how much fun that can be. And basically, we've been slowly cross-platting them. It's the same code base. So at this point where we are is IntelliSense autocomplete and go to definition and all those basic browsing things are all done. And it's the same code. They're not perfectly in sync. Visual Studio Code releases every month. Visual Studio, we have to remember, we do the integrations honestly, we haven't done it enough times for it to have a known cadence at this point, but we try to keep them in sync. So like, for instance, when we did the last VS Code extension update, it brought the C++ 17 features we did for Visual Studio IntelliSense, because every time we go and do a new feature inside the compiler, we also have to do it inside IntelliSense. And so those things come in, and we're really good about release notes for our Visual Studio Code, so it will tell you when we do those things. So what doesn't have right now, the number one most requested thing for this is final references, and that is one of the things they're working on right now. So it's sort of the way things went was extremely basic browsing to light up. Then we did IntelliSense outside of function bodies. Then we did inside of function bodies. We just added like the ability to like get IntelliSense autocomplete on locals and globals very recently, like literally like a month ago. I know how basic this stuff sounds, but that was the only way we could actually get it out in time. Like we wanted to make sure that we made things better. It was amazing how far you could get into it before you would notice that we were kind of cheating sometimes. But that's a fairly complete experience at this point. For the last month or two, we've been focused on making the configuration experience easier, which is why that demo I showed you with the VC package that was just added like in the last month. And now I think the most requested things that we'll do next are CMake, built-in CMake support, and final references. Yeah.
When I have, if I have the Visual Studio, why do I need Visual Studio Code? What is it good
right.
for?
Great. Yes. Oh, no. Visual Studio has a black theme. I have to show a demo. No. All right. So great question. So Visual Studio Code, like, I think our answers to this has evolved, and not because we were like lying before and are telling the truth now, but because our understanding of the universe has evolved as we've spent more time with customers. So when we started, we had this hypothesis, right, which is that there are IDEs and there are editors. And that, just like some people just wanted these like focused tools for certain scenarios. So like you would never get anybody off Vim, and people wanted to use Sublime, and they wanted Sublime because it starts up really fast, and you'd have to, and so that was the original design point, right? We needed to have some reason for you to use ours, and so especially for JavaScript, the debugger was in there, but a very basic, simple functional debugger, and of course the source code control integration. And we felt like that was a design point no one had really hit, and that people would use it. It's a very small team. It's actually a very small team in Switzerland that actually does. If you guys know who Eric Gamma is, he's the patterns guy, right? It's actually he has like 8 guys in Switzerland and like 8 team members in Redmond that are responsible for almost all of the VS Code stuff. It was actually born out of the web editor stuff that we did for the Visual Studio Team System stuff. And then they took that editor and hosted it in Electron, and that's what the first version of VS Code was. Not super sophisticated, but they've been just pounding on it month after month. And then, all of us started jumping on board. My team started about, 18 months ago adding our extension. And so as time has gone by, it's just been amazing to watch it happen. It stopped. I don't think it is that story anymore. I don't think it's like some people want a lightweight editor. Obviously this lets us have a relationship with people who are not going to develop on Windows. Like, I find that people, when I talk to people about C++, they think that like the vast majority of people don't dev on Windows, but actually we find surprisingly a lot of people dev on Windows targeting other platforms, which is why I showed you all those demos, right? We believe in that scenario. It's not like we're not trying to get you to use Windows so that with Visual Studio, we just want to have a great experience, and we know that's the place where we're going to have the best integrated experience. So I don't expect that you'll see like all of those bells and whistles from Visual Studio coming into this. We really will keep all of our deep integration in Visual Studio, and VS Code will be, we'll try to keep it fast and a nice quick editor. And of course, it allows us to have a relationship with developers who won't come to Windows. And that's great. We want them, right? We want everybody to because I find that people want to understand our motivation because like otherwise they don't trust us. Like it's simple. We want you to write code for our platforms. Our platform's not equal Windows. It's just one of them, right? We want you to write code for Azure, and we are going to have the best tools for writing cloud development in the world. That's just the plan. And we have a very, very large and dedicated development team that wants to make it great to develop for the cloud. And we hope that you will come into this thing if you are going to be one of the people who didn't put their hands up at the beginning and said, no, man, you're never going to take my Mac away. I'm not trying to take your Mac away. I just want you to write C++ code using the best tools in the business, targeting whatever of our stuff you can with it. That's it. Cool. Wow, that was a long speech. Okay, you want to see one more thing? I've been told, okay, so like you may have noticed I'm kind of a mouse guy. I know this is a thing that we look down on as programmers, but I'm a mouse guy, so judge if you will. But I have been told, and I am not this guy, but that you cannot do a visual code demo without demonstrating this feature, so I'm going to show it to you. As you saw, I just activated the Vim key bindings for this thing. Yeah. And see, it's like says normal down here now. You can't because I'm in your way. But now, like if I type, I don't even know how to use Vim. This is gonna be great. W. I guess this gets people really excited. Are people like thrilled? Look at, oh my God! Wow! Oh yeah! Okay, I actually only know like one Vim key binding, and that is escape :WQ. Does that? No. Escape W. I don't even know what's going on. All right, I'll stop my stupid demo now. All right, I'll remember to turn that off later so I don't hurt anything.
Do you have a Visual Studio mode in VS Code?
No, I actually think there are. I think somebody wrote a extension for that.
Vim extension for Visual Studio.
No.
I mean, it's VS key bindings. Yeah. A lot of them are the same, but I always get lost, frankly. Yeah. Yes?
Actually, like, I don't know this at all yet, so like, what kind of integrations do you have for cloud development?
What kind of integration do we have for cloud development? So the answer to that is primarily at this point, it's like VC package and the ability to pull things down. There's a lot of connected services stuff in there. The tools for the Azure Sphere thing, which again is sort of our premier starting place for a lot of this stuff. It's quite nice. I mean, like you just click and draw a wizard to wire it up to the cloud service. But you know, the thing that we see people doing most is like VC package install, Azure storage, enter. Then it makes all those things available. There are a lot of Azure tooling inside of Visual Studio that is generic to programming language. But yeah, those are the main ones. Yeah, all right. I'm getting the axe. All right, so talk to you later. Thanks for having me. This is great.